In the vast silence of the cosmos, where light whispers secrets across eons, imagine a dawn not of our sun, but of the universe itself. A moment when the first sparks of creation ignited in the endless night. We gaze back through time, peering into the cradle of existence, where galaxies were born from chaos, their fragile forms defying the void. Yet, what if the light we chase reveals not just beauty, but a shock that upends our understanding of how it all began? The James Webb Space Telescope, our sentinel in the stars, has captured glimpses of these primordial giants, galaxies that shimmered into being mere hundreds of millions of years after the Big Bang, far earlier and more massive than we ever dreamed. Their existence challenges the very timelines we thought immutable, like ancient ruins emerging from mist, forcing us to question the rhythm of cosmic evolution. Picture the universe as a grand tapestry, woven in darkness, suddenly illuminated by these behemoths, structures so vast, so precocious, that they hint at hidden forces at play in the infancy of everything. How could such colossal entities form so swiftly in a universe still cooling from its fiery birth? It is a mystery that pulls us into the depths, inviting us to unravel the threads of creation itself. As we venture deeper into this cosmic narrative, let us set the stage on the grandest scale imaginable, where the universe unfolds like an infinite ocean, its waves of dark matter and energy shaping the shores of reality. The dawn of the universe, that epoch known as the cosmic dawn, stretches back over 13 billion years, a time when the first stars and galaxies pierced the primordial fog of neutral hydrogen, reionizing the cosmos and allowing light to travel freely. The James Webb Space Telescope, launched in 2021 and perched 1 million miles from Earth at the Lagrange Point 2, acts as our time machine, its infrared eyes penetrating the veils of dust and redshift that obscure these ancient realms. Imagine the telescope's golden mirrors, honeycomb-shaped and spanning 21 feet, collecting photons that have journeyed across the abyss, each one a messenger from the edge of observability. These first galaxies, detected in clusters like the Pandora's cluster or through gravitational lensing in fields like SMACS 0723, appear as smudges of redshifted light, their spectra stretched by the expansion of space itself. They formed in an era when the universe was a mere fraction of its current age, a seething cauldron of dark energy accelerating its growth, while dark matter provided the invisible scaffolding for stars to coalesce. Contrast this with our own Milky Way, a relative latecomer at about 13.6 billion years old, dwarfed by these early titans that boast masses equivalent to billions of suns, assembled in what seems like cosmic haste. The scale is staggering. The observable universe spans 93 billion light-years, yet JWST peers to its very fringes, revealing structures that challenge simulations like those from the Illustrious project, which predicted a slower buildup. Emotionally, this immersion evokes a reverence for the fragility of beginnings, how these galaxies, born in violence, mirror the turbulent origins of life on Earth, where primordial soups gave rise to complexity. Layer upon layer, the cosmos reveals its expanse. Vast voids like the Boötes void, empty expanses hundreds of millions of light-years across, juxtaposed with dense filaments where galaxies cluster like pearls on a string. In this landscape, JWST's discoveries, such as the galaxy GLASS-z13, potentially the oldest ever observed at a redshift of 13, paint a picture of a universe that was anything but uniform, with overdensities allowing matter to clump faster than gravity alone might suggest. Philosophically, it stirs a sense of awe, reminding us that we are stardust contemplating its own genesis, our brief lives echoing the eternal dance of creation and expansion. Beneath the visible splendor, hidden signals beckon like encrypted codes from the void, detectable only through the precision of our instruments. JWST's Near-Infrared Spectrograph captures the light curves and spectra of these distant galaxies, revealing absorption lines shifted into the infrared by the universe's relentless stretch. These are not sights for human eyes, which falter beyond the visible spectrum, but revelations born from cooled detectors that sense heat signatures from the epoch of reionization. Consider the anomaly in the galaxy JADES-GS-z14-0, where spectroscopic data shows unexpected brightness in ultraviolet emissions, hinting at massive star formation, or perhaps even population 3 stars, those mythical first stars, pure hydrogen and helium, forging heavier elements in their cores. The tension builds as we decode these emissions. Radio waves from neutral hydrogen at 21 centimeters, stretched to meters by redshift, whisper of the dark ages before stars lit the sky. Gamma rays, though absent here, remind us of the violent bursts elsewhere. But in JWST's domain, it's the subtle dips in brightness, the light curves from transiting phenomena or lensing effects that unveil overabundances of heavy metals in these early galaxies, defying models that expected pristine compositions. Intrigue mounts with each dataset. The telescope's mid-infrared instrument peers through dust clouds, exposing hidden star-forming regions where anomalies like unusually high star formation rates suggest feedback mechanisms, supernovae blasting gas outward, yet somehow accelerating assembly. It's as if the universe is sending us puzzles, each spectrum a Morse code of creation, urging us to question if exotic physics, like varying fundamental constants or primordial black holes, seeded these giants. Grounded in real methods, these detections stem from painstaking calibration, cross-referenced with Hubble's visible light archives, building a multi-wavelength portrait that grows ever more wondrous with each observation. In this shared journey through the stars, we find a gentle warmth, a connection that binds our fleeting human hearts to the eternal pulse of the cosmos. Like wanderers gazing at the same night sky, we reflect on how these ancient lights touch something deep within, evoking a sense of belonging in the grand tapestry. Tracing back to the very beginning, we reconstruct the primordial chaos from which order emerged, a symphony of fire and dust unfolding over the cosmic timescales. In the instance after the Big Bang, the universe was a searing plasma, quarks and gluons dancing in a quark-gluon soup at temperatures exceeding 1 trillion degrees, before cooling allowed protons and neutrons to form. This was the epoch of nucleosynthesis, where helium and trace lithium were forged in the first 3 minutes, setting the elemental stage for all that followed. As expansion continued, the universe entered the Dark Ages, a foggy interlude lasting hundreds of millions of years, where neutral atoms absorbed light, shrouding everything in opacity. Then, slowly, gravity's patient hand began to weave structure from the quantum fluctuations imprinted during inflation, a rapid expansion that smoothed the cosmos while leaving ripples in the cosmic microwave background, those ancient echoes mapped by satellites like Planck. Imagine the first stars igniting like beacons in this murk, their ultraviolet radiation ionizing hydrogen, carving bubbles of clarity that grew and merged, heralding the cosmic dawn. These population 3 stars, massive and short-lived, exploded as supernovae, seeding the interstellar medium with carbon, oxygen, and iron. Elements that JWST now detects in abundance in galaxies like GN-z11, observed at a redshift of 11, suggesting formation just 400 million years after the Big Bang. Philosophically, this birth mirrors ancient myths of creation from void, yet anchored in science. Simulations like those from the Renaissance Project show how dark matter halos, invisible webs of non-baryonic particles, collapsed first, drawing in WAFs to fuel starbirth. Time stretches here, eons compressed into models, evoking a nostalgic reverence for the elemental forces, fire of fusion, dust of remnants, that birthed galaxies far grander than anticipated. Digging deeper into a case study, consider the galaxy MAX S149 JD, lensed by foreground clusters, its light revealing a compact, starburst entity with star formation rates hundreds of times our galaxies, challenging lambda CDM models that predict gradual growth. Reflections arise, how these ancient collapses echo the formation of our solar system from a nebular cloud, or even the slow accretion of planets, reminding us that from cosmic dust, complexity arises layer by layer across the abyss of time. Science becomes a custodian of memory, preserving the universe's autobiography in the form of ancient light and data relics. We analyze photons that have traversed billions of years, their paths bent by gravity, their energies diluted by expansion, yet carrying tales of the past encoded in their wavelengths. Fossils of light these are, captured in archives like the Mikulski Archive for Space Telescopes, where JWST's observations join those of Hubble, allowing us to read the evolutionary history of galaxies through their morphologies. Irregular blobs evolving into spirals and ellipticals over epochs. Particles from cosmic rays, remnants of early supernovae, add to this record, while gravitational waves, though from later mergers, hint at the black holes that may have seeded these first structures. It's a methodical unraveling, blending lyrical wonder with factual precision as we decipher how overdensities in the early universe led to precocious galaxy formation, much like reading tree rings to uncover climatic histories. The voices of evidence resonate through the scientific community, where missions like JWST, a collaboration between NASA, ESA, and CSA, have yielded peer-reviewed findings that stun the world. Researchers such as Brant Robertson from UC Santa Cruz, analyzing data from the JADES survey, reported in 2023 the discovery of galaxies with redshifts beyond 10, their papers in Nature detailing how these entities formed black holes rapidly, perhaps through direct collapse. Telescopes like ALMA complement this, providing sub-millimeter views of dust-enshrouded star formation, while the timeline stretches from JWST's first images in July 2022, revealing Sears 93316, initially thought to be at redshift 16 but refined to 4.9, showcasing the iterative nature of discovery. Human minds, from astronomers like Garth Illingworth to teams poring over spectra, embody this quest, their work a testament to curiosity's triumph. Delving into invisible landscapes, we uncover the unseen architectures that scaffold the cosmos. Dark matter's gravitational embrace, forming halos where visible matter pools, invisible yet inferred from galactic rotations that defy Newtonian laws. Beneath the surface of observation, quantum fluctuations from inflation seeded these densities, creating a web of filaments and voids, with JWST revealing how early galaxies clustered along these dark threads. The suspense builds as we contemplate dark energy, accelerating expansion and diluting matter, yet somehow allowing these massive structures to assemble swiftly, perhaps aided by primordial magnetic fields or exotic particles. Metaphors abound, like roots beneath soil nourishing towering trees. These hidden realms shape the observable, evoking awe for the depths that JWST's infrared gaze pierces, exposing subsurface truths in the cosmic infrared background. Against all odds, life emerges in the harshest realms, much like potential biosignatures on distant worlds mirror the resilience of Earth's extremophiles. Microbes are thriving in scalding vents or Antarctic ice, their metabolic ingenuity paralleling how early galaxies harbored conditions for complexity amid chaos. In volcanic depths, archaea endure pressures and heats that would crush most life. Their persistence a wondrous echo of cosmic endurance, fostering hope that in the universe's dawn, simple chemistries could spark the precursors to biology. Expanding our gaze, refuge worlds like Europa, with its subsurface ocean beneath icy crusts, heated by tidal forces from Jupiter, offer havens where hydrothermal vents might nurture life, much as Enceladus spews water plumes rich in organics, detected by Cassini. Titan's methane lakes and thick atmosphere, explored by Huygens, evoke alien chemistries, while Mars' ancient riverbeds hint at lost habitability. Shocking facts like Europa's ocean volume exceeding Earth's, woven into visions of cosmic possibility, stirring hopeful reflections on life's tenacity across the void. This awareness sharpens through tension, urging us to confront the fragility of our cosmic insights, linking personal urgency to the broader quest for understanding. Human scars mirror these cosmic tales as our environmental collapses, deforestation stripping Amazonian lungs, oceans acidifying from carbon excess, parallel the overzealous star formation in early galaxies that risked burnout. Societal rifts driven by resource wars echo gravitational instabilities that could have torn primordial structures apart, fostering empathy for how our actions scar the planet, much like supernovae feedback reshaped ancient cosmos. The collapse unfolds viscerally, systems unraveling in a cascade. Imagine ice sheets fracturing under warming skies, seas rising to swallow coastlines, biodiversity plummeting as species vanish at rates unseen since the dinosaurs' end. In cosmic terms, overmassive early galaxies might have quenched their own star formation through feedback, gas expelled and outflows detected by JWST, a grave parallel to human-driven tipping points like permafrost thaw, releasing methane, accelerating doom in a feedback loop of intensity. Hidden stakes lurk in the forces propelling discovery, political wills funding JWST amid budget battles, economic interests in space tech clashing with environmental costs, moral dilemmas over prioritizing cosmic exploration while Earth suffers. Historical patterns, from Cold War space races to modern privatizations by companies like SpaceX, reveal conflicts. Global analogies to colonial resource grabs, where scientific progress masks inequities, yet offers paths to unity through shared knowledge. The future balances on our choices. One path leads to dystopia, ecosystems in ruin, societies fractured by climate refugees, space ambitions faltering amid scarcity. The other, hopeful, harnesses renewable energies, international collaborations mirroring JWST's success, fostering sustainable exploration that preserves our world while reaching for stars, emphasizing personal responsibility in this visionary fork. In reflective closure, we tie these threads, the universe's dawn, a symbol of our own potential rebirth, resonating with quiet sincerity. What echoes from the beginning, that cosmic paradox of light born from darkness, reframes our place. Do we dare embrace the mysteries unveiled? Our legacy in light endures through generations, as humanity's journey intertwines with the stars. Survival hinged on ethics that honor the cosmos, lessons from ancient galaxies teaching us to nurture rather than consume, ensuring that what remains is a testament to wisdom across the vastness of time.